Hello students, now I am going to discuss on IC 555 timer where I have shown here the IC diagram, integrated circuit diagram, which consisting of 8-pin IC, which is a DIP IC. DIP stands for dual in-line package. That means equal number of pins are shared on both sides. What are the features of IC timer? Why it is important? Why the name 555 timer? All this we are going to try to understand by looking at the features of the IC 555 timer. What is the purpose of this IC? So mainly it is used to generate a precise time delay. So that means by using 555 timer I can generate a required amount of a delay. So that's the first feature of the 555 timer. The second one, the timing pulses whose duration and frequency are determined by externally connected timing resistor and capacitor. That means the time delay can be controlled by using a RC network besides the time constant. So this is the benefit of the IC 555 timer. So externally by connecting a simple capacitor and resistor, I can determine what is the duration or how much time pulses should be generated. And it is a 8-pin package which consisting of a 8-pin. The name of the pins are designated to the each pins. You can see here where the first pin is ground, second pin is trigger pin, third pin is an output pin, fourth is reset, and eighth is VCC, seventh is discharge, sixth is threshold control voltage. So in this way the pins are designated and to operate via 5 volts power supply. So these are some common features of a IC 555 timer. Now let's look into the aspect of why the name they have given 555 timer, just because it generates a required amount of a precise time delay. But why 555? That is addressed by looking at the internal functional diagram of a 555 timer. So this is the outside diagram, this is the inside diagram of a 555 timer. What are they comprising of? You can see the outside connections also here along with the inside diagram, which is called the internal functional diagram. So first let's try to find the answer why the name 555. Just because the name of the IC 555 because of the fact that internally it consists of 3 5 kilo ohm resistors connected in series. You can observe here from 8 pin to the ground pin. All the 3 resistors are connected in between. So that all of them are same value 5 kilo ohm, 5 kilo ohm, 5 kilo ohm. Because of this they share the name of IC 555. Okay, this is the reason behind that. Okay, now what are it consisting of? Apart from the resistors component here. So here the second point is 2 comparator CP1 and CP2, which is made up of a op-amp device. So both are comparator here, comparator 1, comparator 2. The next stage is the flip-flop stage. We are familiar with op-amp as well as the flip-flop. The flip-flop here we are using is SR flip-flop. Why SR flip-flop is used here? SR flip-flops is mainly used to turn on and turn off the transistor connected here. Also, which helps to drive the inverter, which is connected to the output pin. So that means the RS plays a very important role in deciding whether it should be 1 or 0. Okay, and preceding to this, the comparator will decide to reset or set the flip-flop. Prior to that, we have some voltage connected here. Because of this voltage, 5 kilo ohm, 5 kilo ohm, 5 kilo ohm, and the voltage is tapped in particular node like Vx and Vy. So for CP1, one of the input is tapped from the here from this node, which is Vx node, and what is the voltage applied here? And also for CP2, one of the input is tapped from Vy node. Then what is the node voltage at this point? And also which has got the another 2 terminals will be connected to the respective pins like trigger and threshold. So how this comparator will be operated by considering this inputs? Okay, that is addressed here. The CP1 will produce a positive or logic 1 when threshold input is greater than 2/3 VCC. So that means here the CP1. So basically, when one of the inputs, say your threshold input is 0 now. So obviously the Vx is already, it is 2/3 VCC with respect to the ground at this node. So which is applied here. Because of that, this quantity is more than this quantity. Because of that, it is producing now 0 by default. When this CP1 produces logic 1, so only when your threshold is greater than the Vx voltage, then CP1 turns to 1. What happens to the CP2? You can see here, when the quantity trigger is 0 at the one of the input, and one of the input already is Vy, which is tapped from this point, this node. So already it is 1/3 VCC, which is applied to the positive. Because of this, the comparator will be driven to the high. That is, 1 is already available here. So 1 is applied to the S, 0 is already applied to the R when both threshold and triggers are 0. When threshold input is greater than 2/3 VCC, this will be resetted. So in this way, the comparator will be operated by varying the threshold and trigger. Okay. Also, your flip-flop will be driving the inverter, and from the output of the inverter, it is connected to the output. So in this way, the whole functional diagram I explained here. Also, we need to understand at this Vx node, how are we getting towards the 3 VCC? I have done the calculation part of, you can see here, when I tap from this point, Vx point, with respect to the ground, what is the voltage at this point? That can be found by applying the voltage divider theorem. We know that by applying a node voltage Vx is voltage at across this resistance into the main supply voltage divided by the total resistance. This is the formula given here. Rb plus Rc, this resistance, divided by the complete all the resistance, adding all the resistance into the main supply, which gives you Vx. We know that all of them shares a common resistance, that is 5 kilo ohm. So accordingly, you are going, when you substitute here, you are going to get 2 VCC by 3 or 2/3 VCC. Okay. In a similar way, if I tap the voltage at this node by applying again voltage divider theorem, we are going to get Vy is equal to 1/3 VCC. So in this way, you can understand the ripple five timer features as well as the functional diagram, the complete block diagram, and what are the voltages available and how this comparator works. All this discussion we have done till now. Thank you.